In this video, we'll take a look at the graphs of the sine and cosine functions. You'll also hear them called sinusoidal functions, and that refers to either the sine or the cosine. So let's take a graph of y equals the sine of x as a function. And so you know from the unit circle that certain values of x, the angle measure, have exact values. So it's 0, pi over 6, pi over 4, pi over 3, etc. around the unit circle. The sign of the function is exact, 0, 1/2, square root of 2 over 2, etc. And there's a decimal approximation. So what I'd like to do is take the values of x and sine of x and graph it on a coordinate plane. So when x equals 0, the decimal approximation is 0. So the first coordinate in the function y is equal to the sine of x is 0, 0. At pi over 6, the value is 1/2. So my coordinate system is counting by pi over 4. So I'll go ahead and use pi over 4 next. Is square root of 2 over 2, which is about 7.07. So I'll make this value 1, 0.5, 0.25, 0.75. So at pi over 4, 707 is about here. At pi over 6, 0.5 is close to here. Then at pi over 3, 0.866 is a little higher, and at pi over 2, we have a value of 1. Then it mirrors that between pi over 2 and pi. So we end up back down at 0 when we get to pi. So from 0 to pi, we have a curve with a maximum at pi over 2, 1. So that's the first half of the sine function, from 0 to pi. Then notice at 7 pi over 6 through 2 pi, we are negative. So if we graph at 3 pi over 2, the value is negative 1. At 2 pi, we're back to 0. And it's the same symmetric to the first half of the sine function. So the sine function between 0 and 2 pi has this shape. Now, if you think about the unit circle, when you keep going around and around, what's going to happen is the shape is going to keep continuing forever in both directions. Let me just dot it in. There's another period of the sine function. So the sine function continues like this forever in both directions. So there are 5 key points that we graph and then connect. The 5 key points are the places where you cross the x-axis, the intercepts, zeros, the relative maximum and the relative minimum of one complete cycle or one complete period. So the 5 key points are 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then at 2 pi, we're back at 0. So if we're going to graph transformations of the function, we're going to concentrate on moving those 5 key points and then reconnecting. The period of the sine function is how long it takes to do one complete cycle. So the period of the sine function is 2 times pi. The domain are all the x values. So y equals the sine of x, we can put any value that we want to in for x, and we'll get a value for y. So the domain is from negative infinity to infinity. But the range, notice, the maximum value is 1, minimum value is negative 1. So this function keeps cycling between those two values. So the range includes negative 1 to 1. And then we would call the sine function an odd function. If you were, it's a rotation around the origin of 180 degrees. Or for every xy, there's a negative x, negative y. So that's what the graph of the sine function looks like. We'll do the same thing to get the graph of the cosine function. So if y equals the cosine, notice that we're starting at 1, 1. So if this is 0.5, this is 1. Starting at 1, 1, then we're decreasing until we get pi over 2, which has a coordinate of 0. In between there, we have the values 0.866, 0.707. so it's decreasing. Then when we get to pi, the minimum value is -1. Then, oops, I didn't quite hit pi right there. So at pi, we get -1. At 3 pi over 2, we're back to 0. And at 2 pi, we're back up to +1. So in between here are our graphs, our coordinates 0.866, 0.707, 1/2. And notice if I were to dot in another period of the sine function, or the cosine function, it would look exactly like the sine function moved over. So this is moved 90 degrees. So the 5 key points for the cosine equation, again, are the max, minimum, and the zeros. So the 5 key points are at 0, 0, at pi over, or 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and then at 2 pi, we're back up to 1. So the period of the cosine function is also 2 pi. The domain is the same as the sine function. We can put any value we want between -infinity and infinity. And the range are all values between -1 and 1. And the cosine was considered an even function because as it goes on and on forever, it has a symmetry line is the y-axis, or for every xy point, there's a value -xy on the graph. So those are the basic functions and what they look like. And now we're going to take a look at transformations. How do we graph variations of the sine and cosine functions? So the general form of a sinusoidal function, either sine or cosine, is y equals a times sine or cosine times parentheses bx minus c plus d. So we'll take a look at these one at a time. The first, let's take a look at what a does. A is the amplitude, or a vertical stretch or compression. So the local and maxima and minima will be a distance a above the midline instead of the distance of 1. So if I graph y equals 1/2 sine of x, the 5 key points, let's see, I'll make this 1/2. I'll graph just one period. The sine of x looks like 0. At 1/2 we have 1, or pi over 2. At pi we have 0, 3 pi over 2, -1, 2 pi is back to 0. So what the graph of the sine function looks like is the dotted line. The graph of 1/2 sine of x is, in this case, a vertical compression, 1/2. So that means that our maximum and minimum values on these key points are going to be 1/2 instead of 1. So we still have the zeros at the same place, but at pi over 2, the maximum is 1/2, and at 3 pi over 2, the minimum is -1/2. So the pink graph is the graph of 1/2 sine x. If we were to multiply by 3 or 4, then your graph would have a maximum of 3 or 4 and a minimum of -3 or 4. All right, let's take a look at the cosine. We have y is equal to -3 cosine x, so I've included a reflection with this one. If we start with the graph of the cosine, my amplitude this time is 3, so it's a vertical stretch of 3 and a reflection. So I'm going to go ahead and label the graph so I can fit everything on there. We'll count the vertical axis by 1. So the graph of the cosine starts at 1, goes through 0 at pi over 2, -1 at pi, 0 at 3 pi over 2, and back to 1. So there's the graph of the cosine. Then -3 cosine is going to be an amplitude of 1, 2, 3 instead, and we're going to reflect. So this point at 0, 1 is going to become a coordinate 0, -3. They're going to share the same intercepts. This coordinate pi at -1 is now going to become a maximum at 3. 0 stay the same. So we've got a reflection over the x-axis and an amplitude of 3. So that's a vertical stretch of 3 and then a reflection. All right, then the next item, let's take a look. What does B do? B affects the period. So if you have y is equal to the sine of b times x or cosine b times x, it changes the period from 2 pi to 2 pi divided by b. So it's a horizontal shrink or it changes the period. So the graph of sine equals 1/2 x. Okay, the amplitude is not going to change, so I'm going to label 1, -1. The sine function, I'll put that one first so you can see how these are related. The sine function, there's the original. And then the transformed version, the new period, is going to be 2 pi divided by, in this case, 1/2, which ends up 2 pi divided by 1/2 is equal to 4 pi. So that means it's going to take 4 pi for my graph to happen instead of 2 pi. So I'm going to need a little bit more room. So that means I would start at 0, end at 4 pi. I'll label it over here. The middle, so see how the symmetry of the graph, you have the zeros at the beginning, in the middle, and at the end. So now a 0 would be at 0, 2 pi, and 4 pi. The maximum is halfway in between the zeros, so I would have a maximum at pi and a minimum at 3 pi. So this is the graph of the sine with a period of 4 pi instead of 2 pi, so it's stretched out with the 5 key points. Let's see, graphing y equals cosine 2x. The graph of the original cosine, I'll start with, has a period of 2 pi. And now the new period is going to equal 2 pi divided by b, which is 2. So now the period is pi. So I want this whole thing to happen between 0 and pi instead of 0 and 2 pi. So notice we have a maximum at the beginning and end of the function. So I'll have a maximum at the beginning and at the end at pi. Halfway in between is the minimum. So halfway in between at pi over 2 is the minimum. And then halfway between those, my graph crosses the x-axis. So one period of the cosine function happens between 0 and pi instead of 0 and 2 pi. So that's the period. So now we've taken a look at amplitude and period. We've changed the shape, either a vertical or horizontal stretch. And now we're going to take a look at a phase shift. A phase shift moves the graph to the right or to the left. And it depends on what's inside the parentheses. If y equals the sine of bx minus c, that can also be written as factor out the b times x minus c over b, or y equals cosine bx minus c can be rewritten as cosine b times parentheses x minus c over b. The phase shift is c over b to the right or to the left, depending on this sign. So if I have a minus sign, I'm going to shift to the right, c over b. C is 2 pi over 3 divided by b, which is 2. So 2 pi over 3 divided by 2 means 2 pi over 3 times 1/2 multiplied by the reciprocal. And I end up with pi over 3. Okay? So this graph, y equals the sine 2x minus 2 pi over 3, is going to move to the right pi over 3. Now, what graph is moving? Notice there is no amplitude a, but there is b times 2x. So it's going to shift to the right pi over 3. It's also going to be a change in period. The new period is going to be 2 pi divided by b, which is 2. So I'm going to graph the sine on the period pi instead of 2 pi, and then I'm going to move the entire graph to the right pi over 3. So let me graph the sine between 0 and pi. So this is an intermediate step to get to the... So I've changed the shape. There's the shape of the period of pi instead of 2 pi. Now I'm going to move my 5 key points to the right pi over 3. Pi over 2 is here, so I'm going to move to the right pi over 3 and redraw. And if you want to know what the coordinates are, take each of your key points, 0, 0, and add pi over 3. So that's going to move to pi over 3, 0. The next coordinate at pi over 4, 1 is going to move to pi over 4 plus pi over 3, 0. And then you get your add your fractions together. So you're adding pi over 3 to each of the x coordinates to move your graph to the right pi over 3. All right, let's take a look at a cosine example. Graph y equals the cosine of x plus pi over 4. In this case, the amplitude is 1. I don't have, the period doesn't change. I'm moving my graph to the left because that's positive, pi over 4. So if I start with the original cosine that has a period of 2 pi, that didn't change. And then I'm moving my graph to the left pi over 4. So move each of these key points to the left pi over 4. And redraw your graph. If you want to find what those actual coordinates are, take your key points, 0, 0. It's going to move to the left pi over 4. So that's going to be now negative pi over 4, 0. Take your coordinate pi over 2, or I'm sorry, 0, 1. There we go. Pi over 2, 0. That's going to be pi over 2 minus pi over 4, 0. And you'd get common denominator and add together your fractions. So to move each of the key points, subtract pi over 4 from each of the x values. All right, so now let's put it all together. Oh, we have one more item. A vertical shift up or down, y equals the sine of x plus or minus d, moves the graph up or down d units. And we call something the midline is the line, the horizontal line that cuts your graph in half. It's the symmetry line. So let's put it all together. If you have the graph of y equals a, or the equation a sine bx minus c plus d, or a cosine bx minus c plus d, the steps for graphing, graph your original function and label your 5 major points. Then find the amplitude and period. Sketch a graph with your vertical horizontal stretches dotted with your 5 major points. Then figure out your phase shift, C over B, and if it's moving to the right or left. Identify the vertical shift, whether it's going up or down, and your midline. Then move your 5 major points and draw in the final graph. And you can always check with Desmos. So on the first one, we'll just identify the major features. Given the equation y equals 3 times the sine of 4 times x minus 3 plus 4, identify your a is 3. This one's already factored, so b is 4, c is 3, and d is 4. So the amplitude is 3. The period is 2 pi divided by b, 2 pi divided by 4. Reduce your fraction, that would be pi over 2. The horizontal shift is c over d. So, or c over b. So that would be 3 over 4. If that's a minus sign, we're moving to the right. So the horizontal shift is a positive 3 over 4. Or you can say 3 over 4, select answer, units to the right. And then the equation of the midline is wherever d ends up being. So we're going to move up 4. So the equation for the midline is y is equal to 4. So the midline, take a look at a graph up here, the midline would be the horizontal line that goes through the center of your graph. We didn't shift any of these up or down, so the midline was the y equals 0, or the x-axis. All right, last example. Determine amplitude, period, phase shift, vertical shift, equation for midline, and then graph. So we have y equals 3 times the cosine of 2x minus pi over 3. So our amplitude is 3. There's no reflection. The amplitude is the absolute value of 3, so that's just 3. The period is 2 pi divided by b. In this case, b is 2, so the period of our graph is pi. So I'm going to start, let's see, let me graph the cosine function. I have an amplitude of 3, so I'm going to use a scale of 1, 2, 3, 4. So the cosine function the one in blue is the original cosine function. Now I'm going to graph amplitude of 3 and a period of pi. So this is the second step. The amplitude is 3, period is pi, so I want the whole graph to happen between 0 and pi. So at the beginning and end are my maximum values, in the middle is my minimum, halfway in between are the zeros. So this is the graph of just the cosine function with an amplitude of 3 and a period of pi. Now identify the phase shift. Phase shift, I have a minus, so I'm going to go to the right. Pi over 3 divided by 2. So pi over 3 divided by 2 is the same thing as pi over 3 times 1/2, which is pi over 6. So I'm going to move my graph to the right, pi over 6. And then d, there is no value for d, so the equation for the midline is y equals 0, or the x-axis. So now my final graph, I'm going to take the graph of the shape change and move everything to the right, pi over 6. And then sketch it in. So that's one period of the graph is the one written in black ink. And if you want to find the key points, you have now the 0, your key points in the pink graph were 0, 3, pi over 4, 0, pi over 2, negative 3, 3 pi over 2, 0, and then back at pi, we end up back at 0, or back at 3. So that's the pink graph. And then to get the last graph, we're moving everything to the right, pi over 6. So that would be 0 plus pi over 6. The next one would be pi over 4 plus pi over 6. The next, pi over 2 plus pi over 6. Negative 3. Next point, 3 pi over 2 plus pi over 6. And the last point would be pi plus pi over 6. And again, it's just adding fractions. So you would add fractions, get a common denominator. Pi over 4 plus pi over 6, your common denominator would be 12, to get your key points if you need them. All right, so how do we do this on Desmos? I'll show you one quick graphing on Desmos. You can select your graph settings and type in -2 and type the word pi, pi, to 2 pi, step pi over 4 or pi over 3 or pi over 6, whatever you prefer. And then you can type your function. Make sure that your graph is in radians, and that's where you do that here as well. So zoom square, we're in radians. And then type in your equation. Y equals cosine 2x minus, and then you can type the word pi, pi, divided by 3. And you can check your work. So here's the graph on Desmos. There's pi over 6, 1, 5 pi over 12, 0. So that can fill in your coordinates. Sometimes it'll give it to you in terms of pi. It's if you have your scale set up correctly, and sometimes it'll be to the nearest 3 places.